Use the definition to find the derivative of f of x equals the square root of 5x plus 1, then evaluate f prime of 3. The first thing to do is to write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x, all of this divided by h. The next thing to do is formulate f of x plus h, which means to take f of x, the square root of 5x plus 1, and replace each of the x's with an x plus h in parentheses. So we will have the square root of 5x plus h in parentheses plus 1. Then we take that and subtract from it f of x, which is square root of 5x plus 1. And all of that is divided by h. The next step is to distribute that 5 into that x plus h. So we will have limit as h goes to 0 of the square root of 5x plus 5h plus 1 minus the square root of 5x plus 1, and all of that divided by h. Now we still have the 0 over 0 indeterminate form, and we will continue to have that until we can factor an h out of the numerator to cancel with that h in the denominator. In order to cancel an h out of the numerator, we need an expression involving h that's factorable. Right now we have a difference of square roots, which is not factorable. But when you have a 0 over 0 indeterminate form involving roots, the method by which to rework it is going to be the multiplication by the root conjugate, and that's going to be our next step here. We're going to write down the root conjugate, which is the same two expressions in the root combination, but opposite sign between them, so a plus between them, and then we put that over itself, a form of 1, so we're not changing the value, we're just changing the look. And we're going to now multiply those together. Since the root conjugate pair is in the numerator, we're going to FOIL out the numerators. The first is the root of 5x plus 5h plus 1 times the root of 5x plus 5h plus 1, which is going to be 5x plus 5h plus 1. The outside is the root of 5x plus 5h plus 1 times the root of 5x plus 1. Those can combine together under a single root. Because each of them are under a root. The inside is going to be negative the root of 5x plus 1 times the root of 5x plus 5h plus 1. Therefore, it'll be negative, and they can combine under a single root. They're multiplying each other. And then the last is negative root of 5x plus 1 times a positive root of 5x plus 1, which will be a negative of 5x plus 1. It's really important, though, that the negative is multiplying the entire expression. After the roots multiply, the root and the square cancel, and we get 5x plus 1, but there will be a negative to distribute on each of those. So just be careful with that. And then all of this is over the denominators multiplying each other, which is going to be h times that other expression. We're going to keep that h factored out. Now, after foiling out our root conjugate, the outside and inside terms will be equal value opposite signs, so we can cancel those out. And our denominator is going to be h times, let's keep this factored and not distribute the h in, because our goal is to get that h to cancel with an h that factors in the numerator. So we want to keep it factored out. Our next step in the numerator is to distribute the minus sign into this expression here on the end. so that we can combine together like terms. And we will have limit as h goes to 0 of 5x plus 5h plus 1 minus 5x minus 1, all this over h times the root of 5x plus 5h plus 1 plus the root of 5x plus 1. And combine these like terms together. Remember, at this point, all terms that do not have an h should be canceling. And there's a positive 5x and a negative 5x. There's a positive 1 and a negative 1. And that leaves us with just that 5h. All terms that don't have an h should cancel, because our next step is going to be to factor the h out of the numerator. Well, there is only one term with the h. And then we can cancel that with that h in the denominator. The denominator I'm just going to leave exactly as is, so I'm just rewriting it. Okay, our next step, since that h is multiplying 5 in the numerator, and we have an h multiplying the stuff in the denominator, those h's can cancel. And at that point, we should no longer have the 0 over 0 indeterminate form. Instead, we have a 5 divided by the root of 5x plus 5h plus 1 plus the root of 5x plus 1. And we can now plug in a 0 for any remaining h's, which means this first root will become 5x plus 0 plus 1, so just 5x plus 1, plus the other root, which is also 5x plus 1. Those roots can combine together. There's two of them. So our overall derivative will be 5 divided by 2 times the root of 5x plus 1. So there's our derivative function of x. Now from here, we want to evaluate f prime of 3. That's going to be plugging a 3 in for any of the x's in f prime. So let's do that. F prime of 3 will be 5 divided by 2 times the square root of 5 times 3 plus 1, which is 5 over 2 times 5 times 3 is a 15, and we want to add a 1. So we'll have 5 divided by 2 times the square root of 16. The square root of 16 is a 4, so we'll have 5 over 2 times 4. And 2 times 4 is an 8. So we get 5 over 8.